All right, we'll go ahead and get started. Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about reducing variability in manufacturing with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business practices must be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A. I will get to them at the end of the webinar. So the goal for today is to explore how to reduce variability using Industry 4. To get there, we will first discuss why we should worry about reducing variability in the first place. Then we will also dive into why we should add Industry 4 solutions to existing lean or operational excellence practices. After all, those practices already exist within companies largely to address these sources of variation. So we will cover how they can be supercharged with the smart factory capabilities. Why focus on reducing variability? Instead of working through all of the costs associated with variation in the process, let's do a thought experiment. What would happen if the manufacturing process had zero variability? Well, the most obvious answer is that quality would be perfect. If every item was an exact copy of the ideal, there would be no quality issues whatsoever. So the cost of bad quality would be zero. However, the cost of good quality would be zero also. There would be no need for any testing, for example, because every part is made perfectly in the first place. A little less obvious is that every single type of inventory could also be reduced. Since there's no disruptions to the process, and everything goes exactly as planned, there would be no need to carry the just in case raw materials that most plants carry. Work in process inventory would be reduced as well. No work orders would ever get hung up on the floor for any reason. There wouldn't be any downtime, quality holds, blocked or starved resources due to runtime variation, etc. So even planning and scheduling the plan will be greatly simplified since everything will take exactly as long as it's supposed to. One of the major drivers for finished goods inventory is the amount of variation in the supply lead time. So if the supply chain planners know exactly how long it will take to restock the inventory, they only have to carry enough finished goods to cover the difference between the demand and the supply lead time, plus enough to buffer against demand variability. If all the phases of inventory are minimized, we're also dramatically reducing the cash to cash cycle time, which is the amount of working capital it takes to run the business. This creates enormous leverage for improving the return on invested capital for the business. And also, just imagine the opportunity to drive additional sales if quality was perfect and customer service levels were at 100% every time. Now, you're never going to get to a point where there's zero variability in the plant. It's just not possible. But any step you can take in that direction is going to help with every single one of these different cost buckets. So as far as lean practices go, manufacturing has really embraced technology and automation over the past, well, forever. And continuous improvement and operational excellence teams really have not. And so if you look at how lean practices are done, they're still modeled off of how Toyota did things back in the 60s, 70s, and 80s. And that's great, but there are a lot of opportunities to make it better. So just looking at these boards over on the right side as an example, someone either has to type that information into Excel, post it up on the board. If they write it up on the whiteboards, then they have to come back. Somebody has to come back and type that into Excel later. You could lose all the information if you don't do that at the end of the shift. And so the whole process is very wasteful. There's excess motion, rework, defects, and more. And at this point, these boards are due for some automation. And this is just one quick example of how lean practices and continuous improvement as a whole can be supercharged with Industry 4.0. So let's take a bit of a deeper dive into that. So how do we transform operational excellence? And one way is that if we look at the typical lean management system, where you have kind of the operating system for the business, what are the KPIs that are in place? If you do Hoshin planning, policy deployment, if you look at the visual controls that are in place, how you develop standard work, not just for the shop floor, but for the leadership as well. Looking at the daily accountability process, how you make Gemba walks more effective and so forth. If you look at the lean toolkit as a whole, and you look at kind of higher level activities like root cause analysis or value stream mapping or failure mode and effect analysis, and much more than that. Every single one of those can be absolutely transformed by Industry 4.0 solutions. And over the past couple of months, I've been doing webinars on each one of those and how we can move those forward using the Industry 4 solutions. Now, the pushback that I always get on that is, how do you maintain people's fingerprints on the process if you go to a digital solution as opposed to the manual methods of the past? And I don't want to take too much time in the webinar today, but if you have interest, please reach out to me and we can have a deeper discussion on this. But you can get greater involvement if you put the standard work in place for people to utilize that data in new ways. The involvement simply shifts focus. Instead of doing the grunt work of writing things up on the board or typing things into Excel, people can focus on utilizing that information for improving the process. You can get lasting ownership. So when you build that standard work around the use of the tools, you can build that ownership of that process as well. And if you can improve the understanding, the depth and breadth of people's knowledge about how everything works, you can actually create that better lasting ownership. Visualizing different possibilities is one big advantage of having the software in place as well. And finally, the investment in change. I've been told that if people don't write the numbers up on a whiteboard, that they won't be invested in the change in the process, which frankly, I find ridiculous. In my experience working with operators and supervisors and people from dozens, if not more, of different companies, and probably hundreds of plants that I've been in over the years, they will be invested in the change if they're involved in the process of creating that change. And so it doesn't matter whether the information is written on a whiteboard or if it's coming from a digital display. It's how you build the work around utilizing that data that makes a big difference. So what are the primary causes of variation? And for this, I'm going to structure this around just a typical fishbone or Ishikawa diagram of primary causes, and look at man, machine, method, material, measurement, and environment. And for today's presentation, since we only have 30, 40 minutes, I'll be focusing on man, machine, and method. If there's interest, I can come back and do another session on looking at the material, measurement, and environment sources. From a manpower perspective, some of the primary causes of variation from a manpower perspective, if we look at why most human errors are occurring, is it that they don't have the right information available, or if it's out of date? Do they lack the proper training in how to actually perform the process and so forth? How often are mistakes made due to a lack of knowledge or experience? Does variability increase when new workers come on board? So if you have, significant amount of turnover in your facility, or you have, aging workforce that's, leaving the leaving the plant, and you're hiring new people, how much do those new people struggle to keep the process in line? Is there a wide variance between operators, whether they're new or existing? I've seen plants where there's a 50% difference in how the process operates depending on who's running that process. And how do you actually do error proofing, whether it's in pick and place as an example here, or anything else? But how are you ensuring that that process is as easy to run in the same manner every single time as possible? So how does Industry 4.0 help standard work? And there are a few key principles here. First of all, we have to deliver the right information to the right place at the right time. So everybody needs to have that information that is crucial to them operating the process in a standard way when they absolutely need that information. How can we augment the people in the organization with new capabilities? And I'll be touching on these as I go through. So how do we encourage the adoption of new and standardized work practices? Well, if you have software in place that is helping people and assisting them with running that process, then you are actually guiding them into how they should be running that process the same way every single time. How do you detect and elevate attention to deviations from the standards? So if somebody comes in and on second shift, they turn the dial for setup on the machine differently than what they had it on first shift, how can you identify that and bring attention to that so that you understand that people are not running the process in the same way every single time? And then how do you bring those new workers up to speed much more quickly? So a little bit about the aging workforce in manufacturing. I know this is very common knowledge and so forth, so I won't spend a lot of time on it, but SHRM estimates that within 1 to 2 years, nearly 58% of the manufacturing workforce in the US will be eligible for retirement as the average age continues to rise. That doesn't mean that they will take it, but that they'll be eligible. And that can be a huge, huge problem for companies as they try to recruit and retain new talent. What I have found with my customers is that when they do have that turnover, that it dramatically reduces the workforce efficiency, the quality and the yield can be impacted, as well as the operational costs from a maintenance perspective. How well they run the machine can impact how long, when you have maintenance issues. Safety and compliance can be impacted, and just looking at the training costs themselves and so forth. So how do you turn all of that around with the turnover in the workforce? One way that we can go about this is utilizing augmented reality systems. And whether you're looking at this for initial training, or whether you're looking at this for expert guidance as they're operating the process, the augmented reality solutions can provide a tremendous leg up. First of all, one of the things that I've heard from a variety of different training organizations is that when they do their initial training for their new people coming into the plant, there's a high level of churn. So they go through a traditional training process and they leave the organization right afterwards because they're not excited by it. I mean, it's hard to get a lot of the new generation coming in and being, excited about a career in manufacturing. And so anything that can be done to, first of all, impart that information more effectively, but also in a way that's more interesting to those people, will help retain them a little bit longer going into the process. Their onboarding will be more successful. And then being able to run the process itself and have that expert guidance, as they're doing so, is also, very critical to their initial success with that process, and making sure that people run that process in the same way every single time. And then being able to get remote assistance as well, instead of when an operator has a question, or they need some assistance from engineering or from maintenance or their supervisor or anyone else. Instead of having to wait for somebody to show up at the machine, they can use a mobile device to actually go through and look at what is happening in the process, show that to the expert, and get guidance without having to have that person come to the machine, and thereby reducing the downtime, but also imparting that knowledge to the operator for the future. So the machine itself is another major source of variation, and variability exists in nearly every single machining process or every single operation. And there are improvements that are possible to this from IoT and machine learning platforms. So how can you they assist with analysis across different processes. You can get additional causal analysis by looking at the tag data coming from sensors or from PLCs. You can customize workflow and analysis that's tailored to the environment within the plant. You can get additional contextualization of the data by incorporating downtime data, operator information, material properties, cost information, environmental sensors, etc. You can do alerting based on pretty much any criteria, so that you can get assistance to the machine. You can see when it's heading out of specifications and so forth. And you can finally do predictive analysis with machine learning as well, not just around quality as it says up here, but really around quality, maintenance, tooling usage, pretty much any factor that you would want to do a predictive analysis on. I talked earlier about how you can transform the lean tools themselves. And this is one place where we can look at how you run a typical Kaizen process. There's a number of different ways, but a typical 6-step Kaizen cycle. You identify the problems, you analyze the current process, you create solutions, you test the solutions, you measure and analyze the results, and then you standardize. Every single one of those can be helped by IoT and Industry 4 solutions as a whole. So identifying the problems in the first place, if you have a strong analysis of the different machines within the overall process, you're going to be able to identify where quality issues are happening, where downtime is happening, et cetera. Analyzing the current processes, if I'm grabbing that lower level data and I'm able to see, how does the machine perform when I'm running this material? How does it run when this operator's running the process? How can I utilize this tag information and so forth to predict when some output variable is going to occur, and so forth. All of that is very easy to do with these technologies. Creating solutions, Industry 4.0 has it dramatically expands the solution space that I can select from, as well as being able to help me brainstorm and generate a number of ideas for how to do so. Testing the solutions. If I have a digital twin, one of the possibilities that is out there is being able to simulate the change before I actually implement it. And so I can test it without spending capital to actually adapt the machine in any way. Being able to measure and analyze the results goes back to number one, and being able to track all of those different performance variables on the shop floor. And then standardizing the solution. We talked earlier about how we can impact standard work. And we can blend all of this into that process as well. So just as an example of something that we've done with a customer here, looking at step 2 of that Kaizen process in terms of analyzing the current process and being able to do a loss drill down. For every time that the machine stopped, we gathered information about what area was it equipment loss or production loss or quality loss, et cetera. What category was it in, whether it was the oven or the cooler or wrapping or whatever it might be, and then what was the actual cause, what product was running at the time, and so forth. And so then, as we accumulated this information and drilled into those biggest bars, what we were able to find is that the equipment loss in the oven were the biggest issues. And if we looked at how much we were losing on a daily basis for that, most days we didn't lose much time at all, but then we had these big spikes of downtime. And the primary cause that we identified was actually the pins that were keeping the conveyor in place were breaking within the oven as they got fatigued from going through the heat up and cool down. And so every time that happened, they had to let the oven cool. Then they could get all the burnt bread out of the oven. Then they could fix the problem and restart the process again after the oven heated up again. And so every time that it occurred, it was a major downtime. So because this was only happening periodically, we were able to identify this as a preventive maintenance issue. And we were able to put a PM program in place that switched out those pins when required. And we basically eliminated the single biggest source of downtime in the plant just because we were able to identify what was happening. This is another example that we did with a power company actually. And what we were able to see using some visualizations of this data was that they were having what they called dents in performance, but they were only having those dents pretty much at certain set points. And so then we were able to work with the engineering team to figure out why were those particular set points generating issues, whereas all the other set points kind of in between weren't having the same types of issues. And to perform that analysis, we looked at automating the correlation analysis between different variables on the input side and the process side to those output variables that we were looking at. At another company, we were looking at the tooling, and the tooling was wearing down. This was a grinding machine. And as the grinding wheel wore down, we either had to replace the wheel or we would end up with bad parts eventually. And so what we did was, this is actually a screenshot from very early on in the process, where we looked at a wheel that was known to be at its end of life, one that was known to be already bad, and one that was a brand new tool. And we were able to identify what were the key variables to look at, where we could see from the amount of variation as we were running each part, whether we were at the point in the life cycle where that tool needed to be replaced, or if we were running the risk of creating bad parts. Kind of finally, failure mode and effect analysis, FMEA, is a very kind of high-powered way within manufacturing to look at ways that the process can fail. And certainly variation is one of the ways that the process can fail when you have excess variation. And so what are the different failure modes? What are the effects of those failures? What are the potential causes of those failures and so forth? And then what can we do to both detect and prevent those failures from happening? And so through Industry 4.0, one of the things that we can do is we can capture that information from the machine automatically as much as possible. So we can map from those causes to what can we look at within the machine, and what are the variables that we can look at, what are the tags that we can look at within the controllers to detect when those problems are going to occur, or when they have occurred. And then we can start to look at how frequently those are occurring over time. And we can automatically now basically generate what is the severity, what is the probability of occurrence, and what is our probability of detection. And basically turn an FMEA from a project into something that is live on an ongoing basis and can be used for management of the process and reducing the variability over time. So then we come to method, and we look at how we can impact the sources of variation from the manufacturing method or process. And so a lot of this is just due to work instructions and how people get those work instructions, how much we adhere to the standard work and so forth. And so, how frequently are those work instructions at the line updated? How much of a burden is it to update those work instructions with new products and engineering changes? How often are mistakes made due to workers not adhering to the standard operating procedures or standard work? How are the deviations detected? How often are mistakes made due to workers misinterpreting those work instructions? And so if we look at how to keep those work instructions fresh, typical, book that you put out on the floor, or, work instructions that you have out there. If you think about running the process and then trying to look at these work instructions, you're going to be taking your eyes certainly away from the process, turning your head, reading that paper sheet, even if this is on a screen so that you can keep them up to date more easily. They're still turning their head away from the process and looking at that screen to read the work instructions. With augmented reality, you have that opportunity now to help provide contextual information as someone is looking at the process itself. Not only, in a situation like this, but I've seen examples of using AR for pick and place, where as unit comes in front of an operator, the system will understand what SKU that item is, what parts are required at that station. It will highlight what is the first part that they're supposed to pick or which bin, and then where they're supposed to place that on the unit, and so on for the next part and so forth. And so it very much error proofs that process where somebody almost has to try to do things incorrectly in order to grab the wrong part for that particular unit. Again, the augmented 3D work instructions, as you're operating the process itself, you can see this augmentation as you look at the machine and get everything in context that you don't have to look away. You don't have to keep finding your place on a different screen or on a book to get those work instructions. So some closing thoughts here. I've actually found that the IoT and the machine learning provide significant additions to the traditional tools within lean manufacturing and so forth to combat the machine sources of variation, as well as some things around the method and the person as well, and some of the things that we didn't talk about in terms of the materials and the environment and so forth. But those are essentially enhancements to existing MES systems, to existing OEE systems and so forth, that provide value in those areas and provide capabilities that weren't there previously, but that are really just improvements to existing things. I find that augmented reality is kind of a brand new lever that's available to manufacturers to really help reduce the sources of variation in manpower and in method. And these are things that you simply couldn't do in the past in terms of having those instructions right there, improving the training, and being able to do all these things that you just didn't have the technology for in the past. And finally, in order to be effective, these tools really have to become part of the standard work for the organizations within the company. The example that I use all the time is a Fitbit. I've been wearing a Fitbit since 2013, and I have definitely not lost weight during that time. And it's not that the Fitbit doesn't work. The Fitbit works great. It's just that I haven't changed my behaviors, and I haven't started working out more, eating less, etc. And it's the same thing with these tools on the shop floor. In order to be effective, anything that you implement from a systems point of view or a technology point of view has to become part of that standard work, has to become part of the daily process, has to be accepted into the culture of the organization. Fundamentally, people have to do something differently tomorrow than they do today. Otherwise, you've spent a whole bunch of technology and you're not going to get the benefit that you're hoping for from it. And so those are my closing thoughts. I don't see any questions into the Q&A, but I will follow up with everybody individually after this and see if you have any questions or would like to see anything from a follow-up perspective. So thank you very much for your time this morning. And if we don't talk again before the holidays, happy holidays. Thank you.